Hey gang, this is Mr. Gotch. Ha, you thought it was Batman. Yeah, we're just going to do chapter 6.3 today, properties of trig functions. I might wear the stupid mask, I might not, I don't know. So let's take a look. As we're going through, we got a few goals. We're going to talk about period and signs of trig functions. We're going to find exact values utilizing fundamental identities. And goal number 2, last but not least, find the exact value of trig functions of an angle given one of the functions and the quadrant of the angle. So it's going to be telling where we're going to draw this thing at. Okay, we'll dive into that in a second. So the first thing I want to do is kind of look at what period means. And we talk about a periodic. Okay, function is called periodic if there's a positive number p such that whenever theta is in the domain of f, so is theta plus p. Just remind yourself that we're dealing with a unit circle. We're going around 360 degrees. And what you should know is that when we're talking about sine, cosine, and their buddies, okay, I'm going to circle this in red here, sine, cosine, secant, and cosecant, they start repeating after 360 degrees, okay? So again, the period of these guys starts repeating after 2 pi. Which again is equal to 360. Okay. So you'll start seeing that these reference triangles start repeating after 360 degrees. So when we take a look at the other two, we have tangent and cotangent. They actually only start repeating after pi. Okay, so they start repeating after 180 degrees. So we would say their period for these two would be pi, which is equal to 180 degrees. All right. So again, sine and cosine are their buddies. Their period is 2 pi over 2 pi, which is 360. And then tangent, cotangent, their period is pi, which is 180 degrees. That's when it starts repeating. Okay. So what we have here says use the fact that the trig functions are periodic to find the exact values of the expression. Do not use a calculator. Now, you can use a calculator if you need help. Okay, so if you need 495, okay, and then all I'm going to do is keep subtracting 360 until I get an angle that's between 0 and 360. Okay, and I went ahead and did that, and I got 135 degrees. Okay, so the sine of 495 is the same as the sine of 135. Okay, all right, gang. So what we need to do is we need to draw our initial side, which is always on the positive x-axis, and now we need our terminal side. Okay, so again, terminal side, that's 90, that's 180, that's 270, that's 360, and then 90 plus 360 would be 450, and then 495. Well, that's the same thing as a 135 degree angle. Okay, so that's the idea. So that's about right. The one right in the middle right there. Okay, now when we draw a triangle, we always drop it down. And now we got a nice, pretty right triangle there. All right. So reminder what these angles are. If this is 135 and this guy is 180, then we need to know what this little angle is. So take those two, subtract, and we should know that's a 45 degree angle. Okay. So that's 45 and that's 45 right there. All right. So what are the sides that are across 45? So we've talked about this already. All right. So when I'm dealing with a right triangle, we should know across from 45 is root 2. Okay. So That's a root 2. Now, that's going up. This is going to the left. That is also a root 2, but it's a negative root 2. We're going to talk more about this here in a little bit. Okay. And then last but not least, this guy is a 2. Okay. So we want sine. Sine is equal to O over H. Okay. Well, in our case, opposite from this side, give a little refresher. Opposite, this is opposite. The x-axis is always adjacent. Opposite is always going up and down with our reference triangles, and hypotenuse is always the diagonal. So as we take a look, the sine of 495, the sine of 135 is equal to opposite, which is the square root of 2, and then that is divided by the hypotenuse, which is 2. Okay, so final answer, we should get root 2 over 2 for the sine of 495 or the sine of 135. Okay. All right, next we have 19 pi. And for me, I have no idea what 19 pi is. You can keep subtracting 2 pi, or if you want to convert this thing, okay, I would take the 19 and multiply by 180. The pi's are going to cancel, and I got 3,420. And all you got to do is subtract 360. Subtract 360. Keep going, keep going, keep going. Okay, I eventually get 180 degrees. So I kept subtracting 360, and I eventually got 180. We're trying to get an angle in between 0 and 360. Okay, so the tangent of 19 pi is the same as the tangent of pi, or 180 degrees. Same thing. All right. All right. Well, 180 is one of those quadrantal angles. Okay. So this is 0 right here. All right. So I'll even draw in the little circle. We're talking circles now. Remember, this is 0, 1, 0, and I'll even write these in for our notes today. So reminder, at 0 degrees, using SOHCAHTOA, this is 0, 1, 0. Okay. Up here, for my notes, is IOU, so 1, 0, undefined. Okay. That means over here is the opposite, so that's 0, negative 1, and 0. At 180 degrees, and then down here, I would have negative IOU. Okay. Now, those are, again, in terms of sine, cosine, and tangent. SOHCAHTOA. So over here, we're looking at 180 degrees. That's sine. Sine of 180 is 0. The cosine of 180 is negative 1. And the tangent of 180 degrees, the tangent of 19 pi, is also 0. So final answer, 0. Final answer. Okay. We can do the exact same thing for cosecant. I can take 9 pi over 2 and multiply by 180 over pi. The pi's will cancel, and then 180 divided by 2 is 90, and 90 times 9 is 810. Okay, so you get 810. Well, just keep subtracting 360. Subtract 360, 450. Subtract 360, and I got 90. Okay, so the cosecant of 9 pi over 2 is the same thing as the cosecant of 810, which is equal to the cosecant of 90 degrees. Okay, they're all equivalent. All right, so back up here, we can use that IOU from our quadrantals. This one represents sine, that's cosine, okay, and that's tangent. This is SOHCAHTOA. That's in that order, okay? Well, cosecant is equal to 1 divided by the sine of 90. Well, what's the sine of 90? Look over there. Okay, SOHCAHTOA. So is the first one. 1. 1 divided by 1, my final answer is equal to 1. Okay, so again, we're just reviewing quadrantal angles again. Again, this is the sequence that I use. Those sequence that I use is, again, in terms of SOHCAHTOA. All right, and that should help you guys out. All right, gang, so now we're going to talk about all students take calculus. What this is referring to is the three big trig functions, sine, cosine, and tangent, and identifying who's positive and in what quadrant, okay? So when I'm drawing my triangles, all right, so let me draw some shapes here. When I draw a triangle in quadrant 1, the adjacent side is always on the x-axis. Then I draw up for the opposite, and then I draw my hypotenuse, okay? Well, all of those would be positive. So that means all of my trig functions are positive, all right? Well, then when I go into quadrant 2 and I draw my adjacent leg over, that's going left. That is now a negative value. So the adjacent leg is negative, okay? Well, then when I draw up, that's positive. So I'm using black for being positive, and the hypotenuse is always a positive too, okay? Well, when I take a look, adjacent is negative, so that means tangent and cosine are both negative. The only one that is positive from SOHCAHTOA is sine, okay? All right, I'll put an E there so you guys don't think we're at church. How's that? All right, next in quadrant 3, when I'm drawing, I have the adjacent leg is negative, and then I have coming down is the opposite leg. The hypotenuse is always positive. Okay, so with opposite and adjacent being negative, that's TOA, negative over negative, that is a positive for tangent. But cosine and sine are less than 0 or negative. Okay, so in this quadrant, only tangent is positive. All right. All right, last but not least, quadrant 4. In quadrant 4, I would draw to the right. That's a positive adjacent. But then I would draw down that value for the opposite. And then my hypotenuses are always positive. Okay, so again, tangent's negative, sine is negative, but adjacent and hypotenuse are both positive. So that means cosine is the only one that's positive. All right. So all students take calculus. ASTC is referring to what trig function is positive. All three are positive. Only sine is positive in quadrant 2. Quadrant 3, only tangent is positive. And then quadrant 4, only cosine. All right. Now, if you know those three are positive, then you know their buddies are positive and vice versa. If you know cosecant is negative, like in example 4, then you know his buddy is negative. Who's his buddy? His buddy is what? Sine, and that's going to be less than 0. So sine of, all right, so if you know cosecant is less than 0, now you know sine is less than 0. So we have to know what quadrant is sine negative. Well, I know it's positive up, so that means it's negative going down. Okay, sine is positive in quadrant 1 and 2. They're all positive. Sine is positive, so it means it's negative or less than 0 in quadrants 3 and 4. All right, so I look at the next one. I have secant of theta is greater than 0. Well, if you know secant is greater than 0 or positive, then you know his buddy cosine is also positive, which is greater than 0. All right, so if I'm drawing this out, I'm looking at secant and cosecant. There's going to be secant and cosine. And where is cosine and secant positive? Where is cosine positive? Okay, well, they're all positive in quadrant 1, and cosine is positive in Q4. Okay, so my final answer would be, I would be drawing this triangle in quadrant 4. Right, you can use Roman numerals, IV. All right, so we would be in quadrant 4 for that one. So I take a look. Example 5, I have cosine of theta is greater than 0. We know cosine is positive in quadrant 1 and quadrant 4. Okay. And now where is tangent less than 0? Okay. Where is it negative? Well, I know where it's positive at A and T. Okay. I know it's negative in the other two, S and C. All right. So final answer, where is this thing being drawn? If I had to draw a triangle, I would be in quadrant 4 again. All right. All right. Moving on here, we have some fundamental trig identities that we are not going to use. I'll just introduce you to them today. You've probably seen this before last year. Sine squared plus cosine squared equals 1. If I divide everything by cosine squared, you'll get tangent squared plus 1 equals secant squared. And if you take sine squared plus cosine squared equals 1, divide everything by sine squared, sine over sine is 1. Cosine squared over sine squared is cotangent squared, and 1 over sine squared is cosecant squared. All right. Now you could use these, but it's so much easier. Just continue on what we're doing. Okay. So they're asking us to find the exact values of each of the remaining trig functions. Okay. So the first thing they gave me is cosine of theta is negative 4/5. Well, right there, I know his buddy. I know his buddy, secant of theta, is the reciprocal 5 divided by negative 4. Okay? So if I know A and H, and I'll mark this up here, I know A, and I know this guy right here is H. All right? So I can do secant H over A. All right. Now, they told me cosine is negative, so we know we're in the left-hand side where the adjacent leg's negative. And it also tells me what quadrant we're in. It tells us we're between the angle 180 and 270. And I went ahead and drew that for us here. Here's 180, here's 270. So I'm going to go ahead and draw my initial side. Okay. And then here's theta. Not here, not here. It's in between these two. So I'm just going to make a generic angle there. So theta technically is from here all the way to there. Well, we want to make a right triangle. And now we want to fill in the things that we know. Okay. We know the adjacent leg, which is, again, here's the little angle. Adjacent would be right here. We know that is negative 4. Okay. We know that one's negative 4. We know the hypotenuse is 5, and we know this one's the hypotenuse. So right there is 5. All right. Well, the last thing we need to know is what's the opposite side, and this is where we'd use a little Pythagoras. You can set up a squared plus b squared equals c squared, and go ahead and find that this is a 3, 4, 5 Pythagorean triple. In this case, because it's going down, we should get negative 3 there. Okay, so again, I found negative 3 just by using Pythagoras or knowing my Pythagorean triples. Okay. All right, so if I know cosine, I know secant. Now I got all the stuff I need to find the sine of theta. The sine of theta is, again, O over H, negative 3 over 5. And now I know tangent. Tangent of theta is opposite, negative 3, divided by adjacent, which is negative 4. And you should simplify that to 3 over 4. Okay, remember, tangent is positive in that quadrant. Well, now if I know sine, I know his buddy, cosecant. Remember, buddies start with different letters. So if sine is negative 3/5, then I know this guy is 5 over negative 3, or negative 5/3. And last but not least, if I know tangent, then I know cotangent of theta is the reciprocal 4 divided by 3. All right. So I got my 6 trig functions given everything I needed right there. All right. All right, moving on to number 7. Just want to make sure we're crystal clear on how to do this one. It says I have the sine of theta is 2/3. So right there, I know his buddy. His buddy is cosecant of theta. And just flippy flop. That's 3/2. All right. Now, this is where it's very important. I need to know where to draw my triangle. All right. I already know that I have opposite and I have my hypotenuse, my H. I have O and H. All right. And I got to know where to draw this. Okay. Well, sine is positive 2/3. So that means sine is positive in these two quadrants. All students take calculus. They're all positive here, and sine's positive in quadrant 2. Well, they also told me where tangent of theta is a negative number. Okay. Well, tangent is positive in A and T. T for tangent, A for all. So that means it's negative in the other two. Okay. So that tells me where I'm drawing my triangle. My triangle, okay, will be in this quadrant. All right. So let's put in the sides that we know. We know this guy is 2. We know this guy is 3. All right. Now, how do we find the adjacent leg? This is where, if you need to, go off to the side and set up your a squared plus b squared equals c squared. Okay. For sake of time, I think it's just easier if I can just go through it with you. My c is 3, so 3 squared is 9. This is my a or my b, so 2 squared is 4, so 9 minus 4. Okay. 9 minus 4 is 5, and then I would square root both sides, so I'd get the square root of 5. But because this is in the second quadrant, this guy right here would be a negative square root of 5. Remember, we want exact values, so don't give me decimals here. Okay. All right, so we've got our size. We're ready to go. So cosine. So we're ready to go. Cosine of theta is, again, a over h. Cosine ca, I have negative root 5. Come on. So we're ready to go. We got cosine. Cosine of theta is equal to negative root 5. And that's divided by my hypotenuse. So that's ca. Okay. If I know him, then I know his buddy. His buddy is secant. And that's just flippy flop. That's ha, the funny one, h over a. I'm going to have 3 divided by negative root 5. Okay. Now, for sake of time, I'm going to go ahead and rationalize this, multiply top and bottom by root 5. So I should get 3 root 5. Okay. And then that's all divided by root 5 times root 5 is 5. Okay. And then don't forget the negative in front. All right. So I had to get negative 3 root 5 for his buddy. All right. So let's finish up with tangent of theta. Tangent of theta is, again, opposite, which is 2, And then this is adjacent. So I'm going to get 2 divided by a root 5, which is negative. Okay, now if you leave it like that, you're a dirty rat. So final answer, I'm going to get a negative. Multiply top and bottom by root 5, I get 2 root 5. And then on the bottom, root 5 times root 5 is 5. Last but not least, I have cotangent of theta. Again, A over O, I have adjacent is a negative square root of 5. And that's divided by opposite, which is 2. Okay. So overall, not too bad. Over here, even and odd properties, I don't even worry about. You can look through those. It's just, in my opinion, just easier to draw the triangle. So sine of 30, okay. Up here it says the sine of negative 30 is just the opposite of the sine of 30. So if you want to do the sine of 30 and just put a negative in front, you could. For me, I just think it's easy to say, let's just draw our triangle. This is my initial side. This is my terminal side, 30-degree angle, okay. When we have a negative, we go down. So there's my triangle. Okay. So my angle is a little 30-degree angle right here. Okay. So that guy's 30. Okay. Yeah, it's technically negative 30, but again, we're dealing with a triangle. So it's 30, 60, 90. And we should know what's across from 30s, what's across from 60s. All right. So bring this guy down so we can see it. And I can't. All right. So across from 30 we know is 1. Across from a 60 we know is a square root of 3. And then across from the 90 is a 2. Okay. Now, reminder, if we're going right, that's positive, but when we're going down, that's a negative 1. So don't forget about that. All right, so sine, what's sine? Sine, so is O divided by H. And in this case, opposite is negative 1. Hypotenuse is 2. So final answer is negative 1/2. All right, you can do the exact same thing when you have radians. You can convert this. This is the same thing as the cosine of negative 45 degrees. All right, so let's go ahead and make our little drawing here. Here is my initial side. And here's my terminal side, okay? If I go this way, it's positive. If I go down, that's a negative angle. Okay, so there's about negative 45 degrees about. And now I'm going to draw this guy up. All right, so again, we went down 45. So this is 45, 45, 90. And then we know this is a 2. Okay, this one is going to the right. So this is a positive square root of 2. And this one, again, is going down. We end up with a negative square root of 2. Okay, so final answer, the cosine of negative 45 degrees, again, that's the same thing as A over H. And in our case, A over H, adjacent, next to the central angle is a root 2. So we get the square root of 2. And hypotenuse is 2. Okay. And if you take a look up here, cosine of negative theta is the same thing as cosine of theta. If I drew theta up here, okay, in this quadrant, I would also get a root 2 over 2. Okay, because they're sharing the same adjacent leg. That's the idea. All right, ladies and gentlemen, I hope you enjoyed the class. You guys have a great day. Stay out of trouble, stay healthy, and watch out for the Joker.